Okay, we're going to talk about fertilizers. So you can watch the video here, or you can use the PowerPoint or the PDF. That's entirely up to you. If you're looking for the PDF, always look for the little comments summarizing the things that are here on the video. This doesn't mean anything. It's just a funny picture that I found on the internet, and it's kind of silly to think of fertilizers and toilets, and to me they kind of go hand in hand. All right, the reality is perennials do not need a whole lot of fertilizer. Now, there are some exceptions to this, but most perennials are pretty forgiving. So if you do your bed prep properly, you probably won't need any chemical fertilizer for the first couple of years. If you are top dressing every year with compost, you will probably never need to add any chemical fertilizer. Now, there are some exceptions. You may have clients that insist on fertilizer being added. There are definitely plants that benefit from yearly applications. There may be soils that you're struggling in where they have limited available fertilizer or limited fertility. So sometimes that you might need to add some fertilizer. So this is not a botany class. It is not a plant biology class. But there are 17 basic required plant nutrients. And I always remembered them as C. Hopkins Cafe, managed by my cousin Nimical. Yeah, your cousin kind of has a goofy name, but you have all of them. There are a few plants that require sodium, but most don't. We tend to break these down into macro and micronutrients. Some texts will have you have primary micronutrients and secondary micronutrients, but from my perspective, they're either macro and they need lots and lots of them, or they're micro and they don't need as much. Now, here's the thing. Every single one of them is important. If the plant doesn't have nitrogen, it will die. If the plant doesn't have boron, it will die. Every single one of those nutrients are absolutely essential. They just don't need as much of the micronutrients as they do the macronutrients. So we're going to go through a couple of the macronutrients because you're going to see these are common ones where you have deficiency symptoms. Nitrogen is a very, very common one. And if you look at the yellow and on that leaf, you'll see that it's yellow in between the veins and dark green veins. We call that chlorosis. And since nitrogen is absolutely essential for chlorophyll production, when you don't have enough nitrogen, you can't make enough chlorophyll. If you can't make enough chlorophyll, then your leaves aren't green. Phosphorus is absolutely essential for root growth and flowering. So if you notice where the arrow is here, that's the typical symptom that we see with phosphorus deficiency. The foliage starts to turn a purplish color. But it also means that if you don't have good roots, you don't have good growth. If you don't have good growth, you don't have good flowering. If you don't have good flowering, you don't have good fruiting also. So it can kind of make your fruit taste a little bit funny. Potassium is absolutely essential for water relations. That's the important one here. Yes, it's needed for protein synthesis, but it's really necessary for water relations. So the problem is when you have a potassium deficiency, it looks a lot like drought stress. So you get these curling of the leaf tips, you get marginal necrosis, you sometimes get these purpling spots on the underside. So it looks sometimes like drought stress, and you think, oh, I need to water my plants, when in reality it's not a lack of water. It's a lack of the ability for the plant to control water going in and out of the leaves. As we talked about with bed prep, how do you know how much to add? Well, you need a soil test. For perennials, if you are using a complete fertilizer, we are going to base our calculations only on nitrogen. The only exception to that is going to be if you do a chemical soil test and it reveals there are problems with other nutrients. I wouldn't personally do a chemical soil test until I noticed that there were really weird things happening within my plants, especially if I'm fertilizing with either compost or a complete fertilizer that has all of the macro and the micronutrients in it. So, what is the recommended rate for perennials? 1 pound of actual nitrogen per 1,000 square feet of bed per year. 1 pound of actual nitrogen, which I abbreviate AN, per 1,000 square feet of bed per year. That's it. It's a very, very small amount. Now, are all fertilizers created equal? So let's analyze this and see if we can figure this out. So I'm going to pick on Scott's a little bit. First off, you'll notice they have things like lawn food. Well, why do they call it food? Plants make their own food. They don't they don't need us to provide them food. It's almost more like lawn vitamins, if you want to look at it that way. So let's click on any one of these and see if we can't find our N, P, and K. That's the usual thing that we're worried about. And yes, happens to be a turf one. You could find these things for just about anything that you're looking at. So it's not easy to see right away, but we can scroll and get the basic information on this. As you'll notice, you can't see it right away on the product. If you were in the store, you'd have to pick it up. And if we kind of scroll down, we can take a look. There's your fertilizer analysis, 3204. Now, could I use this on perennials? Technically, it's not. Again, it's not legal because of the label, but perennials can't tell the difference between turf fertilizer, perennial fertilizer, or houseplant fertilizer. As far as they're concerned, all nitrogen is nitrogen. They don't need turf nitrogen or garden nitrogen. All right. There are some changes with organic fertilizers. We've seen a lot more numbers and a lot more types of organic fertilizers coming out. They usually have lower nutrient content, which means it's difficult to burn your leaves. They often don't have as many formulations, but that doesn't seem to be a huge problem for most people. You can find pros and cons for both organic and inorganic fertilizers. The plants can't tell the difference between an organic nitrogen and an inorganic nitrogen. So that's more personal preference and up to you. Burning plant roots is all a matter of amount. You can burn plant roots with organic fertilizer. It just takes a lot more. The cost is coming down as more and more people are wanting to do or use organics. And you can have leaching with organic fertilizers in the same way that you can have leaching with inorganic fertilizers. You just have to apply a lot of them. Now, here's some of the bad stuff. We create about 7 million dry tons of sewage sludge. Roughly 50% of that is reapplied back to the land somewhere. In the Pacific Northwest, they're a little bit better, and they get about 90% of it. The rest is either burned or put into a landfill. If it's burned, they can often use that to create electricity. Lots and lots of cities are now composting their biosolids. It's not necessarily recommended for your food and your vegetable gardens, but for ornamentals, it's perfectly fine. Now, here are some of the challenges that we have. We utilize a lot of fertilizers, and whether you're coming from an agronomy perspective, a golf course perspective, or an ornamental perspective, or a lawn care perspective, we apply a lot of chemical fertilizers, whether they're organic or inorganic. And when we apply too much or apply at the wrong time, that stuff leaches out into the soil, gets into the watering system, and eventually makes its way down into the Gulf of Mexico. So if we take a look at this picture here, the Gulf of everything that's green there, that's all algae. There's nothing else there but algae. There'll be no fish, there'll be no other plants, and so it ruins a lot of different things. So that's one of the bad things about it. And I'm sure you've heard this happening here in Ohio as well, because it does happen in Ohio, where runoff from chemical applications creates the algae to just go crazy. And some of those algae are actually toxic to people. They produce byproducts that are toxic to people and pets. And so you'll have these times where you're not even allowed to go swimming. I'll let you kind of click through that if you want to, but basically I'm sure you've driven past or seen ponds or gotten the alerts that says don't go in the water right now because of the harmful algae. So that can be a problem. We are causing that problem. We can reduce some of those problems by reducing the runoff. If we cannot reduce the amount of fertilizer that we utilize, we can perhaps reduce the runoff. And one of the ways to do that is to have a green roof, because that slows water runoff and allows the plants to absorb the water rather than it going into the sewer system. So the take-home message here is that ornamental applications, depending upon the source that you're looking at, can account for somewhere between 50 to 80% of our nutrient runoff. We shouldn't need to add to that, particularly if you're growing perennials. Why do we need to add to the problem? Perennials are very low fertilizer plants. And if you're able to use compost, you should not need to use chemical fertilizer most of the time. I want you to think of ornamentals as everything from gardens to lawns to golf courses. So gardens may be a very small part of this, but if we don't need to add them, why would we? Now, I'm not here to tell you do or don't. That's going to be between you and your clients and or your customers. But keep that in mind. So if we look at something like this perennial garden can look this lush without any chemical fertilizer simply by using compost every year. All right, so one of the things that you have to do is do some calculations. So like the organic amendments calculations, we always start by calculating the square footage of your bed. So if your bed here is 25 by 75, you multiply those together, you get 1,875 square feet. Here's where things are going to get different. Step 2, you divide your total square footage by 1,000. Now, where did I get 1,000? That comes from the 1 pound of nitrogen per 1,000 square feet per year. So you divide 1,875 by 1,000, you get 1.875. This is not pounds of fertilizer. This is pounds of nitrogen that's needed for this bed. I still have to convert that into how much fertilizer am I going to need. I do it by asking myself this question. How much of my fertilizer gives me the total that I need? Which sets up this equation. So how much of my given fertilizer, in this case a 20% nitrogen, gives me the amount of nitrogen that I need? Then you can simply solve for X. Another way to look at it, you might be able to see this right away. You take your square footage, divide that by 1,000, you divide that by your percentage of nitrogen. So in this case, to solve for X, X equals 1.875 divided by 0.20. And that gives you 9.375 pounds of fertilizer. So if you have a 20% fertilizer, so hypothetically in this problem your fertilizer was say a 20, or 20 whatever, we're not even worried about these other two numbers. We're only worried about this. This is a direct percentage of nitrogen. Right? So this is the amount of actual nitrogen that we need. This is the amount of the fertilizer the number of pounds of fertilizer that we need to apply 1.875 pounds of nitrogen over that entire bed for the entire year. So you'll need about 9 pounds. Here's where Carmen gets a little weird. If you mathematically enter 9.375, that is correct. If you mathematically enter 9.4 and round that up, that's correct. Nobody in their right mind is going to actually apply 9.4 or 9.375 pounds of fertilizer. They're going to apply 9. 9 mathematically is not correct, so Carmen will probably mark it wrong. I will go back and regrade them all. So I'm well aware that there's a bit of a range that is acceptable. There's the mathematical answer, and then there's the practical answer, and both of those are correct. So do the practice quiz on Carmen. Set yourself up for success by doing that, and then when you're ready during the week, take the full quiz. As always, if you have questions, don't hesitate to get in touch.